Imagine a world where one tiny gram of fuel could power your car for 30 years. Or where entire cities could be powered by fuel that is not only incredibly abundant, but also much safer and cleaner than anything we use today. For years, scientists have been exploring new energy sources that could replace fossil fuels, and one of the most exciting possibilities is thorium. Welcome to Galaxy TVs. We are absolutely delighted to have you with us, whether you are visiting for the very first time or you are one of our esteemed subscribers. Your presence adds immense value to our community, and we genuinely appreciate the time you take to engage with our content. If this is your first time here, we warmly welcome you. We encourage you to explore our diverse range of videos and become part of our vibrant online family by subscribing to Galaxy TVs. To our ever-esteemed subscribers, thank you for your continued support. Your engagement inspires us to create even more exciting content. Don't forget to hit the notification bell. This way, you'll be the first to know whenever we post new videos, ensuring you never miss out on our latest adventures and insights. Thank you for joining us on this incredible journey. Considering Stephen Hawking, one of the greatest minds in modern science, once predicted the rise of an incredibly powerful fuel. He speculated that it would change the world in ways we could barely imagine. This fuel might be here already, and it's called thorium. Today, we're going to take a deep dive into thorium, why it's being called the fuel of the future, and how it could completely revolutionize everything, from how we drive our cars to how we explore the universe. Now, let's dive deep into it. We're living in a world that's desperate for better energy solutions. Fossil fuels, like oil and coal, have powered our cars, homes, and industries for more than a century, but they come with big problems: pollution, climate change, and the fact that these resources are running out. So, scientists and engineers have been hunting for alternatives, cleaner, more efficient, and more sustainable fuels. You may have heard about hydrogen or electric cars. Maybe you've even heard of methanol or ammonia being used as alternative fuels. While all of these have their merits, none of them offer the kind of mind-blowing potential that thorium does. Thorium is a fuel source that could give us massive amounts of energy, enough to power cars, planes, and entire cities, all while producing very little pollution. But why haven't we heard more about it? Well, the story of thorium is still unfolding. So, what exactly is thorium? Thorium is a naturally occurring metal that is found in the Earth's crust. Its chemical symbol is Th, and it has an atomic number of 90. It looks a lot like silver, but unlike silver, thorium is slightly radioactive. The amazing thing about thorium is that it's much more abundant than uranium, the fuel we currently use in most nuclear power plants. Thorium can be found all over the world, especially in countries like India, Australia, Norway, and the United States. While we've known about thorium for a long time, it hasn't been widely used as a fuel, at least not yet. But why is it such a big deal? Well, when you use thorium in a nuclear reactor, it can produce an incredible amount of energy, far more than burning fossil fuels like oil or coal. And here's the kicker: thorium reactors are much safer and produce less dangerous waste compared to uranium reactors. To understand thorium's potential, we need to take a quick look at nuclear energy. In a nuclear reactor, energy is generated by splitting atoms in a process called nuclear fission. When the nucleus of an atom is split, it releases a huge amount of energy in the form of heat. This heat is then used to generate electricity. Most nuclear reactors today run on uranium. But uranium has its downsides. It's not very efficient, it produces a lot of long-lived radioactive waste, and there's always the risk of a nuclear meltdown, like the infamous disasters at Chernobyl and Fukushima. Thorium, however, works a little differently. In a thorium reactor, thorium itself isn't directly used as fuel. Instead, when it's bombarded with neutrons, it turns into uranium-233, which is a highly efficient nuclear fuel. This process generates a lot of energy, but without many of the risks associated with uranium reactors. Thorium reactors also produce far less radioactive waste, and the waste they do produce is much safer and breaks down much faster. Plus, thorium is not weaponizable, meaning you can't easily use it to make nuclear bombs. Thorium has some huge advantages over uranium, which is what makes it so exciting for scientists. Safety. Thorium reactors are much safer than uranium reactors. Because of the way the thorium fuel cycle works, there's a much lower risk of a reactor meltdown. Even if something goes wrong, the reactor will naturally shut itself down instead of spiraling out of control. Less waste. Uranium reactors produce a lot of dangerous, long-lived radioactive waste. Some of this waste stays dangerous for thousands of years, which means we have to store it in secure facilities. Thorium, on the other hand, produces far less waste, and the waste it does produce is much less radioactive and breaks down in just a few hundred years instead of thousands. Abundance. Thorium is 3 to 4 times more abundant than uranium. While uranium is concentrated in a few countries, thorium can be found all over the world, which makes it a much more reliable fuel source. Efficiency. Thorium reactors are also more efficient than uranium reactors. A small amount of thorium can produce far more energy than an equivalent amount of uranium or fossil fuels. For example, just 1 gram of thorium can produce as much energy as 28,000 liters of gasoline. Let's look at the potential of thorium-powered cars. Imagine a car that you never have to refuel, not for a week, a month, or even a year. How about 30 years? That's the potential of a thorium-powered car. The idea is simple. Use a tiny amount of thorium in a car engine. The thorium would generate heat through nuclear fission, and that heat would then be converted into electricity to power the car's motor. Just 1 gram of thorium could provide enough energy to drive a car for millions of miles. Theoretically, this kind of car would be incredibly efficient, producing almost no harmful emissions. Plus, because the energy comes from nuclear fission, it wouldn't require any fossil fuels, meaning the car could run clean and green. However, while this idea is incredibly exciting, it's still mostly theoretical. Right now, we don't have the technology to build a working thorium-powered car, but several companies and inventors are working on it. In fact, back in 2009, Cadillac unveiled a concept car called the World Thorium Fuel Concept, which was designed to run on thorium. It wasn't a functional car, but it showed that car manufacturers are seriously thinking about this technology. Other companies, like Laser Power Systems, are also exploring ways to make thorium-powered cars a reality. They haven't built a working model yet, but the dream of a thorium-powered car is still very much alive. Thorium research in India. While thorium-powered cars are still a dream, one country that is leading the way in thorium research is India. India has some of the world's largest thorium reserves, and the Indian government has been investing heavily in thorium research. India's goal is to develop a series of thorium-based nuclear reactors that could help meet the country's growing energy needs in a safe, clean, and sustainable way. India's most ambitious project is the Advanced Heavy Water Reactor, HWR, which is designed to use thorium as its primary fuel. This reactor is still in the experimental phase, but if it works, it could pave the way for a new generation of thorium reactors around the world. However, India faces several challenges. Developing thorium technology is expensive, and there are still many technical hurdles to overcome. But if India succeeds, it could become a global leader in clean nuclear energy. India isn't the only country interested in thorium. Here's a quick look at how other countries are approaching thorium research. Australia. Australia has massive thorium reserves, and many scientists believe it could become a key player in the global thorium market. However, Australia hasn't invested heavily in thorium research yet, but it has the potential to supply thorium to other countries that are developing thorium reactors. Norway. Norway is also working on thorium technology. In fact, it has conducted several successful tests of thorium-based reactors. Norway sees thorium as a potential solution to its energy needs and a way to reduce its dependence on fossil fuels. The United States. The U.S. was once a leader in thorium research but shifted focus toward uranium reactors during the Cold War. However, there's renewed interest in thorium, especially as the U.S. looks for ways to reduce its carbon footprint. Some private companies in the U.S. are exploring thorium reactors as a potential solution. Nigeria, South Africa, and Morocco. Both Nigeria, South Africa, and Morocco have significant thorium resources. While they aren't yet major players in the thorium industry, these countries could potentially supply thorium to other nations in the future. Thorium and space travel. Now, let's talk about space. One of the most exciting potential uses of thorium is in space travel. Imagine a spacecraft powered by thorium, capable of traveling for decades without needing to refuel. This could make long-distance space travel possible, opening up new opportunities for exploring distant planets and even other star systems. The idea is that thorium, with its incredibly high energy density, could be used to power space missions for years without the need for refueling, something that's currently a major challenge in space exploration. NASA has already shown some interest in using thorium-based power systems for space exploration. Since space travel requires a tremendous amount of energy, the ability to use a compact and efficient fuel like thorium could make future missions much more feasible. One potential application is in spacecraft propulsion. Thorium could be used in a nuclear thermal rocket, which would be far more efficient than current chemical rockets. Right now, most rockets are powered by chemical fuels, which burn quickly and provide a lot of thrust, but aren't very efficient for long-distance travel. A nuclear-powered rocket using thorium could generate much more energy, allowing spacecraft to travel faster and farther without needing to carry tons of fuel. Thorium reactors could also be used to power space colonies or bases on other planets. Imagine a base on the Moon or Mars powered by a thorium reactor, providing clean, reliable energy for years without needing constant resupply missions from Earth. This could be a game-changer for space exploration, making it much easier to establish permanent human settlements on other planets. The challenges of thorium. So, if thorium is so great, why aren't we already using it everywhere? Well, there are some significant challenges that need to be overcome before thorium can become a mainstream energy source. Technological hurdles. One of the biggest challenges is the technology required to build thorium reactors. While we've been using uranium-based reactors for decades, thorium reactors are still relatively new and underdeveloped. Developing the technology to safely and efficiently use thorium as a fuel is going to take time, money, and a lot of research. Cost. Building a new type of nuclear reactor isn't cheap. Thorium reactors require a high upfront investment, and for many countries and companies, it's easier to stick with existing uranium-based technology, which is already widely understood and in use. The cost of developing thorium reactors, from research to construction, can be a major barrier. Fuel cycle complexity. While thorium itself isn't a direct nuclear fuel, it has to be converted into uranium-233 before it can be used in a reactor. This process, known as the thorium fuel cycle, is more complicated than the uranium fuel cycle we use today. Developing the infrastructure and technology to efficiently manage the thorium fuel cycle is another big challenge. Political and regulatory barriers. Nuclear energy is a highly regulated industry. Any new type of nuclear reactor has to go through extensive testing and approval processes before it can be used. This means that even if the technology is ready, it could still take years or even decades before thorium reactors are approved for widespread use. Plus, the political landscape surrounding nuclear energy is complicated. Some countries are hesitant to invest in nuclear technology due to fears about safety, nuclear proliferation, and public opposition. Public perception. Speaking of public opposition, nuclear energy has a bit of a PR problem. Many people associate nuclear power with disasters like Chernobyl and Fukushima, and there's a lot of fear and misinformation about the safety of nuclear energy. Convincing the public that thorium is a safe and reliable energy source could be a major challenge, even though thorium reactors are much safer than traditional uranium reactors. The future of thorium energy. Despite these challenges, the future of thorium as an energy source looks promising. As the world grapples with the climate crisis and the need to move away from fossil fuels, thorium could become a key player in the global energy mix. Sustainability. Thorium is a sustainable energy source that could help reduce our reliance on fossil fuels and cut down on greenhouse gas emissions. Unlike fossil fuels, thorium doesn't produce carbon dioxide when it's used as fuel, which makes it a clean energy option for the future. Thorium is also abundant and widely available, which means we wouldn't have to worry about running out of fuel anytime soon. This makes it a long-term solution to the world's energy needs. Innovation and research. More and more countries are starting to invest in thorium research, and as technology improves, the barriers to using thorium as a fuel will start to come down. New advancements in nuclear technology could make thorium reactors more efficient, cost-effective, and easier to build. In the coming years, we may start to see pilot projects and experimental reactors that use thorium as a fuel. These projects could provide valuable insights into how thorium reactors work in the real world and help pave the way for larger-scale adoption. Energy independence. For countries that don't have access to large uranium reserves, thorium could be a way to achieve energy independence. Since thorium is widely available, countries wouldn't have to rely on foreign imports of uranium or fossil fuels. This could have significant geopolitical implications, as energy independence is a key factor in national security. Hawking's prediction in the future of energy. Now let's circle back to Stephen Hawking and his prediction. Hawking predicted that a new type of fuel could be developed that would be incredibly powerful and could revolutionize the world. Thorium fits this prediction in many ways. While it's not yet widely used, the potential of thorium to become a major energy source is undeniable. The idea of using thorium as a fuel has been around for decades, but it's only now that we're starting to see serious interest and investment in thorium technology. Hawking's prediction may soon become a reality, as more countries and companies realize the benefits of thorium and start working on ways to make it a viable fuel source for the future. The dawn of a new energy age. So, what does the future hold for thorium? While it's still early days, thorium has the potential to change the way we think about energy. From powering cars for decades without refueling to sending spacecraft on long journeys through space, thorium offers possibilities that seem almost too good to be true. But with the right investments in technology and research, we could be on the brink of a new energy age, one where thorium powers everything from our homes to our vehicles, all while keeping the planet clean and safe. The road to making thorium a mainstream energy source won't be easy, and there are still many challenges to overcome. But if we can solve these problems, thorium could become one of the most important fuels in human history, just as Stephen Hawking predicted. Thank you for watching. If you enjoyed this deep dive into thorium and its potential, make sure to like and subscribe for more fascinating videos about the future of energy, technology, and science. Stay tuned for more content, and let's keep exploring the exciting possibilities of the future together. Let us know your thoughts on thorium in the comments below. Could thorium be the fuel of the future? What other alternative fuels are you excited about? Let us know your thoughts in the comments box. We'll see you in our next video. Bye.